Good morning, Algebra 2 students. How are you doing? I hope everybody is done well. I have not checked in on the quizzes. That will happen sometime pretty soon. But just so you know, with some more lessons here, and so at least for the next week, you're going to be learning material again, making sure to fill out all of the forms needed for that. So, with that being said, bless you, and we're ready to start off with our day here at 7:05 in the morning on March 27th. So we're going to look at solving equations in various different ways. We've been talking about radical expressions where you've got roots, various different roots, square roots, cube roots, and all those things. And so today we're going to talk about actually solving problems that have those roots in them. And there's two main ideas that are needed in order to do them. First of all, you think about the radical itself as being its own entity, as its own group, its own variable almost, if you will. So your first job is to isolate the radical, and then your second job would be to use the index to help you figure out how to free up the things that are under the radical. Best way to understand what those mean is through some examples, so I have a few of those. As always, make sure that you pause the video when needed to either catch up on writing things down or anticipate the step, or even trying to get ahead of me and fast forward just fine. So if there's a question asked in a video review ever, if you watched the whole thing or if you skipped around, skipping around is fine. There are things at the beginning and the end that you really need to hear. All right, so we're going to isolate the radical. So what that means is you're thinking about this as its own thing that we're going to get by itself. So I'm thinking about this in red as being its own variable. So in order to get rid of this minus 3 that's here, you do what you would always do and add 3 to make that gone. So after we add the 3, we end up with 5 on the other side. And then the second part is that you use the index. Okay, this is a hidden index. Remember, if it's a square root, the hidden index is 2. And in order to eliminate a 2 in the index, you need to square both sides. You're doing basically inverse operations here so that you can get the things by themselves. All right, so if the radical has got a 2 for an index, you square both sides to make them cancel out, if you will. Okay, so what we then end up with is we end up with 4x plus 1 having to equal 25 in order to have a result of 5 at the end. And so in order to finish this off, you need to do your regular algebra, which is subtract 1 from both sides and then divide by 4, and you arrive at the result. Now, when you do these type of problems, square roots or especially square roots, especially even roots, can have some strange things sometimes. Now today, all of the answers, when we've done them correctly, will check out, right? But you really need to get in the habit, especially when you're doing roots and radicals, to plug in the answer at the end to see if it worked. So even though you might not like to do it because of some things that'll come down the road with it, it's just an important thing to kind of make yourself do the check. So for the check, I want to take this 6 and I want to plug it back into the original half of the equation anyway, just to make sure that my answer comes out to be 2. So when I do that, 24 plus 1, 25, and the square root of 25 minus 3 does equal 2, and it checks out. All right, let's take a look at another one. It's same basic pattern, okay? What I would like you to do is I would like you to kind of anticipate this yourself, see what you can do with it. So if you need to pause and see what you can do and then check in on the answer, that would be great. But once again, we're working to isolate the variable, or the radical, sorry, which I'm thinking about as a variable. This would be almost like if we were thinking about this as being 4a plus 2 equals 14. So you would want to take away the 2. So you get 12. We're still trying to isolate this variable. So we have this 4 on the outside, so you can divide both sides by 4. And then we have our radical is now isolated. Use the index to determine which power. Once again, our index is that hidden 2 for a square root. And so we need to square both sides. And in squaring both sides, you end up with 3x equals 9. Therefore, x equals 3. And once again, we do want to pay particular attention to the check on this. So we'll plug it back into the original part of the equation. 4 times the square root of 3 times 3 will actually give you 3. So 12 plus 2, 14. And yes, that actually checks out. That's good. All right, so that's we've done so far with index of 2, but of course there's other indices that you could possibly have. And you'll see the pattern here pretty quickly. Here we have a cube root. So we're going to once again isolate this radical. This whole thing you want to think of as being one variable. You want to do the same thing to get everything away from that. So we'll take away the 1. And then because it's a cube root, okay, our index is 3, so that means you need to cube both sides. So index equals 3. So you cube both sides to make that go away, because a cube root cubed makes those things cancel out, and you just have x plus 2 equals negative 64. So making your answer be negative 66 when you subtract the 2 from both sides. Once again, we want to pay attention to your check. So we'll just put in a little check here where we plug in your negative 66 plus 2 plus 1 from your original problem to make sure it works. Negative 66 plus 2 is negative 64. And because negative 4 times negative 4 times negative 4 gives you 64, we get negative 4. Adding 1, you get negative 3, and there you have it. It did check out. We're good. You did your work correctly, and you're ready to go with another problem. Okay. Now this one, radical expressions. Now, a radical expression can be hidden in a fractional exponent. Okay, we know that here the 3 represents the power and the 5 represents the index for the root. So what you really want to do is you want to isolate this whole thing that has the exponent of 3/5. Okay, just like that. This is the thing you want to isolate. And so you're really dealing with basically 3a plus 1 equals 25. So you take away 1 like normal. Then you've got 3 times the variable, this one big variable that you're considering all together that's circled or highlighted in red. So divide both sides by 3. So you're left with that. Then step 2, use the reciprocal of the fractional exponent. Okay, remember what a reciprocal is when you flip over the fraction. And the reason this helps is because power to a power is going to end up making them cancel out. 5/3 is our reciprocal of our exponent. We want to take both sides to the 5/3 power. Because look what happens here. Power to a power multiplies exponents. 3/5 times 5/3 is 1. So that's why x plus 1 is now completely freed up. But we have the cube root of 8 to the 5th power, which is not really too hard because the cube root of 8 is 2. And 2 to the 5th power is 32. And then you can easily take away 1 and get 31. And you've solved this thing that looks like it was going to be super difficult, but not if you take it one step at a time. We do, of course, need to then remember to check, put it back into the original problem. 3 times 31 to the 3/5 power. 32 to the 3/5 power, remember, is really the 5th root of 32, and then cube it. That's a 5 there. So that's 2 cubed, which is 8. And then put all those things together and you do get 25. And it checks out. I think we have just a little bit more here to go through. And then you'll get a chance to work on your assignment, hopefully get that out of your road, and have a good weekend. All right, once again, we've got a radical to isolate. The radical includes the thing with a fractional or a rational exponent. So x plus 3 to the 2/3 power. Try this one on your own if you would pause it and just see if you can get this without help. All right, but this is the steps. We need to divide both sides by 2. X plus 3 to the 2/3 power. The reciprocal of the exponent. Oh, there we go. Reciprocal of the exponent is what we need to look at next, which would be 3/2. Because when you multiply, when you take both sides to the 3/2 power, it ends up 2/3 times 3/2 gives you 1, and it cancels out. Because x plus 3 to the 1st power is just x plus 3. Then this, remember, this is the index, this is the power, so it's the square root of 4 to the 3rd power, which is 2 to the 3rd power, which is 8, which gives you 5. All right, so one last thing to do, of course, we need to check it, put it back into the original problem. 2 times 5 to the 2/3 power, really 2 times 8 to the 2/3 power, cube root of 8. The denominator is your index, and then the exponent is the square. Square it, finish, and it checks out. All right, with that being said, that wasn't too long of a lesson today, and it's up to you to practice as always and get good at it so that come test or quiz time, you're going to be in good shape. And do remember to keep looking at this as, knowing that this at home is not forever. So you do need to make sure you're working and practicing your skills. All right, that being said, I hope you all have a wonderful, amazing, blessed day and a really good weekend. Find some time to get some relaxing time in along with that. And then Monday morning we'll hit the road ready to go again, or hit the internet ready to go again. Take care and God bless.